Hi everyone, in this video we will talk about matrix formulation of the multiple regression model. As always, let's start with a simple case first. So consider a simple regression, linear regression yi equal to beta naught plus beta 1 xi plus epsilon I for I equal to 1 to n. If we actually let I equal to 1 to n, we see that we will obtain n equations, right? So we would have y1 equal to beta naught plus beta 1 x1 plus epsilon 1, y2 equal to beta naught plus beta 2 x2 plus epsilon 2, and it would go to yn equal to beta naught plus beta 1 xn plus the nth error term. Well, that's pretty inefficient way of writing it all out, right? So as you can see, there is a pattern that is emerging. By taking advantage of that pattern, we can instead formulate this simple linear regression function in matrix notation. So if we were to do that, we could write this y as a vector, y1, y2, yn is equal to 1 x1, 1 x2, 1 xn, beta naught, beta 1 plus epsilon 1, epsilon 2, epsilon n. So this is our vector of y, which is equal to matrix x times matrix beta, let's call this beta, plus the error term. Now what does this statement mean? Now what it means is that x is an n cross 2 matrix, y is an n cross 1 vector, beta is a 2 cross 1 column vector, right? 2 rows and 1 column, and this is a n cross 1 vector. The matrix X and vector B are multiplied using the technique of matrix multiplication, and that it gives you, so this is going to give you, let me change the color. So this multiplication is going to give you a vector, all right? And that vector is added to the error term using the technique of matrix addition. So this is matrix multiplication. And then you add this and this. You do it using matrix addition. So for those of you who are a little bit hazy, what is a matrix? A matrix is an R, let me use a different color. An R cross C matrix is a rectangular array system, right? With R rows and C columns. So for example, if you have a 2 by 2 matrix, let's say 3 by 2 or 2, let's say 2 by 2 to keep it simple, 1 2 5 4. This is a 2 by 2 square matrix. Okay, so then there is a column vector that we have column vectors. So column vector is an R cross 1 matrix. That is a matrix with only one column. A matrix with only one column. Similarly, a row vector is a matrix with only one row. So this would be something like, let's say, column vector Q 2 5 4. What's a row vector? Is a 1 cross C matrix, a matrix with only one row. Only one row. So let's call it R 2 6 2 9, let's say. And a scalar is a 1 by 1 matrix, right? If you're thinking of everything in terms of matrix. So it's just an ordinary number such as 29, 25, 5, whatever. So now let's see how does the matrix multiplication work. Matrix multiplication. Recall that we have y equal to x beta plus L. It's an example of matrix multiplication. Now there are some restrictions. You can't just multiply any two old matrices together. True matrices can be multiplied together only if the number of columns of first matrix, columns of this matrix is equal to rows of the second matrix. If the number of rows of resulting matrix and the number of rows of resulting matrix is equal to number of rows of first matrix, and the columns is equal to the number of columns of second matrix. So let me put it this way. So if you multiply A by B, A is A cross K, and B has K cross B dimension, then the multiplication of this is, if this is C, this should be same, right? That's the first rule. And the resulting matrix would have these dimensions, A cross B. Sorry. So now we know we can multiply two matrices together. How do we do it? So basic rule, A row to column multiplication, A by B to get C. So basic multiplication rule is to get C, multiply rows of A by columns of B. Ith row and jth column C is inner product. So we use the inner product. So C is equal to A times B. Let's say 197,812, 3215, 5473, 6968. It's going to give you 90, 101, 106, 88, 41, 38, 27, 59. So the first row and the first column. So C, this first row, let me just show you what I'm talking about. This row and this column. So C11, first row, first column, is equal to 1 times 3 plus 9 times 5 plus 7 times 6, 90. Or let's take another entry. C23. So this is the second row and third column. Right, so that would be 8 times 1 plus 1 times 7 plus 2 times 6, which is 27. This row and this column, second and 3, 2, 3. C, second row and third column. This one here is C11. Now when it comes to matrix addition, you just add the entry in the first row, first column of the first matrix to the entry in first row and first column of the second matrix. So I will leave that to you. So now let's coming to least square estimate and get to least square estimates in matrix notation. So if you have the P cross 1 vector containing P parameters of regression function can be shown to equal B. So B is same as beta naught hat. Beta naught plus beta 1. Let's just call it hat. Doesn't really matter. Some books use B instead of using hat because that saves them the pain in typing everything in LaTeX. So that is given by X transpose X inverse X transpose Y, where this X transpose X inverse is inverse matrix of X transpose X, and this is transpose of X. So if you have never studied matrix algebra, or if you have just so totally wiped it off from the files in your brain, so let's go off and review inverses and transpose. So what is transpose of a matrix? Transpose of a matrix A is a matrix A transpose or AT whose rows and columns whose rows are the columns of A and whose columns, so basically rows and columns have been swapped, and whose columns are the rows of A, all in the same order. So if you transpose, if your matrix A is 1, 5, 4, 8, 7, 9, it's a 3 by 2 matrix. A transpose is a 1, 4, 7, 5, 8, 9, 2 by 3 matrix. So since X is a matrix in simple linear regression, X is equal to 1, 1, 1, x1, x2, xn, X transpose X would be 1, 1, 1, x1, x2, xn multiplied by 1, x1, x2, 1, xn. And if you multiply it, you would get n sum xi, sum xi, sum xi square. Now, one more thing that you need to, few more things is definition of the identity matrix. What is identity matrix? The square n by n identity matrix is denoted by IN. It's a matrix with ones on the diagonals and zeros elsewhere. So it would be 1, 0, 0, 0. So for example, if it's a 2 by 2 matrix, I2 would be 1, 0, 0, 1. The identity matrix plays the same role as the number 1 in ordinary arithmetic. That is, if you have multiply a matrix by another an identity matrix, you would get the same matrix. What else do we need to know? We need to know the definition of inverse matrix also. And that's where we will stop. So what is inverse matrix? A inverse is called inverse of a square matrix. A square matrix A is the unique matrix such that is a unique or the unique matrix such that A inverse A is equal to I is equal to A times A inverse. So that is the inverse of A is the matrix A inverse that you have to multiply by A in order to obtain the identity matrix. You see why we needed the definition of identity matrix. The inverse only exists for square matrices, remember. Square matrix. Finding inverses is really messy, so the good news is that we will always let computers find inverse for us. So remember, you can use this beta hat in terms of matrix algebra is X transpose X inverse X transpose Y. We will talk about it in class. And this part here for a simple linear regression is basically sum xi, sum xi, sum xi square. Actually, when you expand it, you will get the same equations, two equations for beta naught and beta 1 hat, right? Like you were having when we were dealing with it in a non-matrix world. So I will stop here and I will see you guys in another video.